What if the way cars have been built for more than 100 years is suddenly about to look ancient? What if the future of car manufacturing doesn't involve endless assembly lines, thousands of welds, and hundreds of parts moving from one station to another? What if one giant machine could do the work that used to take an entire factory floor? That idea sounds almost too extreme to be real, but that's exactly why Tesla has everyone watching. Because while most automakers are still improving the old system piece by piece, Elon Musk is chasing something much bigger. He wants to change the system itself. And at the center of that plan is a machine so massive, so powerful, and so controversial that many believe it could completely reshape the industry. It's called the Gigapress, and if Tesla gets this right, the company may not just build cars faster, it may force the rest of the auto world to admit that the old way of doing things is already becoming obsolete. To understand why this matters so much, you first have to understand how cars are normally made. And once you do, Tesla's idea starts to look less like a wild experiment and more like a direct attack on one of the biggest inefficiencies in industrial history. Traditional car manufacturing is incredibly complex. At first glance, most people don't realize just how many separate pieces go into making one vehicle. A car may look like one finished product from the outside, but underneath that surface is a giant collection of stamped parts, welded supports, brackets, subframes, rails, mounts, panels, crossmembers, reinforcements, and structural pieces that all have to come together in the exact right way. Some are made in-house, some come from suppliers, some arrive from completely different facilities. And then, once they all show up at the factory, the real challenge begins. That challenge is the assembly line. And for decades, the assembly line has been treated almost like sacred ground in the auto industry. It's where everything happens. Robots weld, workers inspect, machines stamp, components get aligned, fastened, measured, tested, and adjusted. One section at a time, one operation after another. It works, but it's also brutally complicated. Every new part adds another step. Every joint adds another opportunity for variation. Every weld adds another chance for weakness, and every handoff between systems creates another possibility for delay. When you zoom out, you realize the whole process depends on thousands of small things going right at the same time. And when even one thing goes wrong, the effects spread fast. That's one of the biggest hidden problems with the traditional system. People think the challenge is just building the car, but the real challenge is coordinating everything around it. You need the right parts in the right place at the right time. You need tools calibrated perfectly. You need robots and humans working in sync. You need suppliers to hit deadlines. You need transport schedules to hold up. You need quality control to catch problems before they become expensive disasters. And all of this has to happen while the company is also trying to keep costs down, improve safety, raise output, and stay competitive. So even though the system has been refined for generations, it still carries a huge amount of friction. It still burns time. It still burns money. And it still forces automakers to accept a level of complexity that most people never see. Tesla looked at that system and asked a question most legacy automakers never seriously asked. Why are we still doing it this way? That question sounds simple, but in an industry this old, it's almost dangerous. Because once you ask it, you're no longer trying to optimize the old process. You're starting to challenge its entire existence. And that's exactly what Tesla did. Instead of accepting a vehicle as something that has to be built from countless smaller pieces, Tesla started asking whether large sections of the car could be made as a single piece, not assembled, not stitched together, not welded from dozens of components, just formed in one shot, one process, one massive structure. And once that idea took hold, everything began to change. That shift in thinking is what made the Gigapress so important. Tesla didn't just buy a bigger machine for the sake of headlines. It used that machine to erase huge chunks of manufacturing complexity. What used to take 70, 80, or even 100 individual parts could now be produced as a single aluminum casting. That's not a small improvement. That's a complete rewrite of the manufacturing logic. Instead of spending time producing, moving, aligning, and joining dozens of components, Tesla could create one solid structure and send it directly into the next stage. That means fewer parts to track, fewer welds to make, fewer weak points in the final vehicle, fewer opportunities for a mismatch, and far fewer steps in the factory. Suddenly, the assembly line starts to shrink, not because the company is cutting corners, but because the process itself is becoming simpler at the structural level. And that simplicity is where the real power of the Gigapress begins. Because reducing parts doesn't just save time, it changes everything connected to time. Logistics become easier. Quality control becomes more focused. Inventory management becomes simpler. Labor demands shift. Space inside the factory opens up. Maintenance on some systems drops. Even the number of robots needed in certain zones can be reduced. This is why Tesla's move matters so much beyond just engineering. The Gigapress is not just about metal shaping. It's about collapsing entire layers of manufacturing burden into something far leaner. That's why this machine is so important. It's not simply doing the same job faster, it's changing what the job even is. So what exactly is the Gigapress? The easiest way to understand it is to think about molding. But on a scale so extreme, it almost sounds absurd. Most people have seen how simple molded objects are made. A material is heated until it becomes liquid. That liquid is injected into a mold, the material cools, and a finished shape comes out. The same concept applies here, but instead of making small objects, Tesla is using this idea to create huge structural sections of a car. The material isn't plastic, it's molten aluminum. The mold isn't handheld, it's enormous. And the force involved isn't small, it's measured in thousands of tons. This is why the name sounds so dramatic. Because the scale really is dramatic. Inside the Gigapress process, aluminum is heated until it becomes molten, then injected into a die under extremely high pressure. That die already contains the exact shape of the structural part Tesla wants to create. Once the metal enters, it has to rush into every corner of that mold quickly and evenly. Then it cools, solidifies, and becomes a finished casting. That alone sounds impressive, but the real story is in the precision. This isn't a crude pouring process. It's an engineered event that depends on exact timing, exact temperatures, exact pressure control, and extremely careful flow management. If the metal is too cool, it may not fill the mold correctly. If it's too hot, that can create its own problems. If the flow isn't right, air pockets or defects can form. If the cooling isn't controlled well, the final structure can be compromised. So while the idea looks simple from the outside, the execution is anything but simple. That's what makes Tesla's use of this technology so interesting. Many people hear about the Gigapress and assume it's just brute force, a giant machine smashing out giant parts. But that misses the deeper point. The real power here comes from combining size with control. It's not enough to have a big machine. It has to be precise. The die has to be engineered correctly. The alloy has to behave the right way. The cooling systems have to be tuned. The sensors have to monitor everything. The process has to produce consistent results again and again. And when you're working at this scale, even a small mistake becomes expensive fast. A flaw in one small part is annoying. A flaw in a giant structural casting is a serious problem. That's why this technology took years of development. Tesla wasn't just building a machine. It was building an entirely different rhythm for the factory. The reason all of this matters becomes obvious when you look at what the Gigapress replaces. In a conventional setup, a major rear structure might be made from dozens of pieces. Each one needs its own tooling, handling, inspection, and place in the assembly process. Then those pieces need to be aligned and welded together. Every weld has to be correct. Every junction has to meet design tolerances. Every attachment point has to line up. If even one area is off, it can affect strength, safety, or later assembly stages. By contrast, a single casting removes a huge amount of that complexity in one move. Instead of hoping dozens of parts come together perfectly, you create the whole section at once. That doesn't just remove work. It removes sources of instability. And that gives Tesla a major advantage in speed and consistency. Then there's strength. This is one of the most talked about benefits of giant castings, and for good reason. When a structure is made from many parts, every connection becomes a potential weak area. Even when the joints are strong, they still represent changes in load paths and potential stress concentrations. A single-piece casting can reduce that. With fewer joints, the structure can behave more like one continuous unit. That can improve rigidity and reduce some of the compromises that come with piecing things together. Now, that doesn't mean every casting is automatically superior in every scenario. Engineering still matters. Design still matters. Crash behavior still matters. But in general, reducing the number of joints opens the door to a stronger and cleaner structural solution. And for Tesla, that's a huge part of the appeal. Speed is another massive benefit. In manufacturing, time is money in the most literal sense possible. Every extra step adds cost. Every extra minute reduces output. Every delay at one station can create a bottleneck that drags everything behind it. So when Tesla replaces a multi-stage assembly with one casting process, it isn't just saving a little time, it's compressing the timeline in a way that affects the entire factory. More cars can move through. Fewer assembly operations need to happen downstream. The production system becomes more direct. That helps with scale, and scale is where Tesla has always tried to win. The company doesn't just want better products. It wants a system that can produce them fast enough and cheaply enough to pressure the rest of the market. Cost reduction may be the most disruptive part of all, because if Tesla can remove dozens of parts, reduce labor intensity in certain areas, shrink the number of steps in manufacturing, and simplify the factory layout, then that directly affects the economics of every car it makes. Lower complexity can mean lower cost. Lower cost can mean higher margins, or it can mean lower prices. And if Tesla chooses to use those savings to cut prices, that's when the pain spreads across the industry. Competitors already struggle to match Tesla on speed and software in some areas. If Tesla also gains a structural manufacturing advantage that lowers cost at scale, then legacy automakers face a much bigger threat than just competition. They face a company that is attacking their cost structure from underneath. This is why the Gigapress isn't just another flashy Tesla story. It points to a deeper strategy. Tesla has always shown a willingness to rethink systems that other companies treat as fixed. Battery packs, software updates, direct sales, charging infrastructure, vertical integration, factory design, again and again, the company has tried to cut through layers of convention. The Gigapress fits that pattern perfectly. It asks a brutal question. If a 100-part solution can be replaced by a 1-part solution, why keep pretending the 100-part solution is still the smartest way forward? Legacy companies often move more slowly because their systems are built on decades of investment. They have suppliers tied into old architectures, factories built around established workflows, and cultures shaped by caution. Tesla has fewer emotional ties to that past. That makes it more dangerous. And Tesla isn't talking about this in theory. It's already being used in production. This is what makes the story so powerful. If the Gigapress were just a lab experiment, it would still be interesting. But it's not. Tesla has already used giant castings in vehicles like the Model Y, especially for the rear underbody, and later for the front structure as well. That means the company has already moved past the concept stage. It has already been shown that this approach can be integrated into real products at real volume. And once that happens, the conversation changes. No longer is the question, could this work? Now the question becomes, how far can Tesla push it? That question is where things get even more fascinating, because Tesla's long-term vision seems to go beyond just replacing a few major structures. The real dream is much larger. Fewer castings, fewer separate modules, fewer steps between raw material and finished vehicle. In the most extreme version of that vision, the assembly line itself starts to fade into the background. Not completely disappear, at least not right away, but lose its central role. Instead of building cars from a vast network of smaller operations, the factory of the future could revolve around a handful of giant production events. Large castings on one side, battery integration and final assembly on the other hand. The car becomes less like a puzzle and more like a set of large finished building blocks. That possibility is what makes people talk about a one-piece car, even if the phrase is more symbolic than literal right now. The idea is not necessarily that every inch of the vehicle becomes one giant piece tomorrow. The idea is that Tesla keeps reducing the number of major structures that need to be assembled from many smaller parts. It keeps pushing the logic of integration further and further. The front structure is one casting. The rear structure is one casting. The battery pack serves as part of the structure. Other modules simplified. The more Tesla can combine, the more it can erase traditional complexity. And that's where the future starts looking radically different from the past. Imagine what that does to the layout of a factory. Today, car factories are sprawling systems full of dedicated stations, tools, transport flows, and handling operations. Material has to move all over the place. Large teams and machines operate in carefully timed sequences. But if major sections arrive already formed, the job of the factory changes. It becomes less about building the structure from scratch and more about bringing together already complete modules. That could mean smaller footprints in some areas, fewer welding stations, less internal movement, faster line flow, more predictable outputs, a very different kind of industrial environment. And if one company reaches that point significantly before everyone else, the competitive gap could become brutal. But this is also the part where the hype can run too far ahead of reality. Because while the benefits are real, so are the trade-offs. And Tesla's critics are not wrong to point out that giant castings create their own problems. The biggest and most obvious one is repair. In a traditional multi-part structure, a damaged area can sometimes be fixed or replaced in a more targeted way. But when a large section of the vehicle is one casting, damage can become much harder to deal with. A problem in one part of that casting may affect the whole unit. That can mean more complicated repairs, higher replacement costs, and new challenges for repair shops and insurers. This is one of the most important weaknesses in the giant casting approach, because even if manufacturing gets more efficient, ownership costs after an accident may rise in certain cases. That creates a strange split in the story. For Tesla, giant castings can be amazing in the factory, but for customers and insurers, they can introduce new headaches after the sale. And that matters, because a manufacturing breakthrough is only truly powerful if the full life cycle of the vehicle still makes sense. If the car is cheaper to build but much more expensive to repair after minor structural damage, then some of the savings simply reappear in a different place. That doesn't mean the technology fails, but it does mean the story is more complicated than the hype suggests. And in many ways, that makes it even more interesting. Because revolutions are never clean. They shift advantages from one part of the system to another. They solve one problem while creating new ones. Manufacturing defects are another major concern. When you produce many smaller parts, one defective piece is frustrating but manageable. You isolate the issue and scrap that one component. But when you're making a massive structural casting, a defect can wipe out a much larger amount of value in one shot. A tiny issue in metal flow, cooling, or internal integrity can potentially ruin the whole part. That means quality control has to be incredibly strong. Inspection methods have to be reliable. Process stability becomes everything. And as Tesla tries to scale this technology further, the stakes get even higher, because the larger the casting, the greater the cost of failure. Then there's machine dependency. The Gigapress is not a normal piece of equipment. It is a gigantic, expensive, highly specialized machine. If one goes down, it's not like replacing a small tool on a side station. It can disrupt a major section of production. This creates a form of centralization. Traditional manufacturing spreads work across many stations. Giant casting concentrates more value into fewer machines. That creates efficiency, but also vulnerability. If the machine needs maintenance, if there's a software problem, if a die issue appears, if throughput drops unexpectedly, the impact can spread across the line quickly. Tesla is basically choosing a system with fewer moving pieces overall, but more dependence on a few extremely important pieces. That's a powerful strategy when everything works. It becomes a risk when it doesn't. Flexibility is another hidden issue. One reason traditional manufacturing evolved the way it did is that smaller components can be easier to modify individually. If engineers want to update a certain section, that change can sometimes be isolated to a smaller set of tools and parts. But with giant castings, major design changes can require significant die redesign. And dies at this scale are not cheap, fast, or simple to rework. That means Tesla has to be more confident earlier in the design process. It has to think carefully about what it locks in. A world built around giant castings may reward bold decisions, but it may also punish rushed ones more severely. Crash behavior adds one more layer of complexity. It's easy to hear fewer joints means stronger structure, and assume the story ends there. But crash safety isn't just about being strong. It's about controlling how energy moves through the vehicle in a collision. Engineers have to design structures that deform in deliberate ways to protect occupants. So whenever a company changes how a major section is built, it has to rethink energy absorption, load transfer, repairability, and crash outcomes. A one-piece structure may offer advantages, but it also demands incredibly careful design. This is why Tesla's manufacturing shift is not just a factory story. It's also a deep engineering story. The machine may be dramatic, but the real success depends on what the vehicle does after it leaves the machine. And yet, despite all those risks, Tesla keeps pushing. That alone says something important. The company clearly believes the upside is worth the danger. It believes that simplifying production at the structural level can unlock so much value that the trade-offs can be managed. And if Tesla is right, the reward is massive. Faster output, lower complexity, stronger integration, better scaling. Potential cost advantages that ripple through the business. Factories that look nothing like the old ones. A car that feels less like an assembly of hundreds of compromises and more like a deliberately formed product. That is not a minor efficiency gain. That is a potential reset of industrial logic. This is also why the rest of the industry can't ignore it. Even automakers that don't fully copy Tesla may feel pressure to rethink how many parts they use, how much they rely on traditional body-in-white processes, and how aggressively they pursue structural integration. Because once one company proves that a simpler architecture can work at scale, everyone else has to explain why they're still doing things the hard way. And that's where Tesla has often been most disruptive. Not by making competitors copy every move exactly, but by forcing them to rethink assumptions they once treated as untouchable. The Gigapress also fits into a larger pattern around Tesla's identity. Elon Musk has long pushed the idea that manufacturing itself is a product. That may sound abstract, but it matters. Most companies focus on the car as the product. Tesla often seems to treat the factory as equally important. In that view, the machine that makes the car is not just support equipment, it's part of the competitive edge. If the factory can produce with fewer steps, fewer parts, and fewer delays, then that factory becomes a weapon. The Gigapress is one of the clearest examples of that thinking. It turns manufacturing from a background process into a frontline strategy. And maybe that's why this topic feels so huge. Because it's about more than Tesla. It's about what happens when an industry built on layers of tradition runs into a company willing to throw those layers away. It's about what happens when the most boring part of business, production methods, suddenly becomes one of the most important battlegrounds in the future of transportation. Most people look at new cars and focus on range, performance, software, or price. But underneath all of that is a simpler question. How efficiently can the company actually build the thing? Tesla seems to understand that better than most. What makes this even more dramatic is that the Gigapress story touches both ambition and risk at the same time. On one hand, it feels like a glimpse of the future. Giant machines are replacing endless assembly complexity. Whole sections of a car appear in minutes. Factories are becoming smaller, faster, and more direct. On the other hand, it also feels fragile. Huge upfront costs, repair complications, dependence on precision, difficult redesigns, high consequences when defects occur. In other words, it feels exactly like the kind of move Tesla loves to make. Bold enough to change the game if it works. Dangerous enough to create serious problems if it doesn't. That tension is what keeps people watching. Because the Gigapress is not just a machine, it's a bet. A bet that simplicity at scale can beat decades of industrial convention. A bet that fewer parts can produce better outcomes. A bet that one giant leap in manufacturing can do more than hundreds of smaller improvements. And Tesla is making that bet in public, with the entire industry watching. Every factory deployment, every production milestone, every repair debate, every cost discussion, all of it becomes evidence in a much bigger argument about what the future of making cars will look like. If Tesla succeeds, the consequences could reach far beyond its own factories. Suppliers built around old body architectures could feel the pressure. Competitors could be forced to spend billions rethinking plants and platforms. Repair networks might have to adapt to new realities. Insurers might have to recalculate how vehicle damage is valued. Even the workforce inside factories could shift as some tasks become less central and new technical demands emerge elsewhere. This is how real industrial change spreads. Not all at once, but through a chain reaction. One company proves something, others respond. Entire support systems start to move around the new center of gravity. And still, for all the talk of giant machines and futuristic casting, the biggest idea here may be the simplest one. Tesla looked at a system full of unnecessary complexity and decided not to accept it. That mindset is what makes the Gigapress story so powerful, because the real breakthrough wasn't only engineering. It was questioning the assumption that complexity had to remain. Most industries are full of processes people no longer question because they seem too established to challenge. Tesla looked at one of the biggest and oldest of those processes and asked whether it could be stripped down dramatically. Whether that gamble fully pays off or not, that question alone has already changed the conversation. So when people ask whether the Gigapress is the future of car manufacturing, the answer may be bigger than yes or no. The machine itself may evolve. The exact implementation may change. Competitors may adopt different versions of the idea. Some trade-offs may grow more visible. Some expected benefits may turn out smaller or larger than predicted. But the direction is hard to ignore. The industry has now seen that large-scale casting can do real work in real vehicles at real volume. That changes what is imaginable. And once that happens, the old way no longer feels permanent. That's why this matters so much. Not because one machine is impressive, even though it is. Not because Elon Musk made another bold claim, even though he did. It matters because it reveals a very different vision of manufacturing. One where the factory is simplified from the inside out. One where a car is made from fewer, larger, smarter pieces. One where speed, strength, and cost are attacked at the same time. One where the assembly line loses some of the control it held for generations. And one where the companies that adapt fastest may leave the others behind. In the end, the Gigapress may become one of those turning points people only fully understand years later. Right now, it still feels like a mix of breakthrough and controversy. A machine surrounded by hype, promise, and very real trade-offs. But that's usually how major shifts look in the moment. They don't arrive as neat victories. They arrive as pressure. Pressure on old systems. Pressure on old assumptions. Pressure on competitors who suddenly realize the rules may be changing faster than they expected. Tesla has built its reputation on creating exactly that kind of pressure. And with the Gigapress, it may be applying that pressure to the deepest layer of the auto business itself. So the real question isn't just whether Tesla can build giant castings. It already can. The real question is whether Tesla can turn that capability into a lasting manufacturing advantage that others can't easily match. If it can, then this won't just be another Tesla innovation story. It will be the moment the industry started moving away from the old world of hundreds of parts and towards something radically simpler. And if that happens, the biggest shock won't be how massive the machine is. It'll be how quickly the rest of the industry starts looking outdated beside it.